We finally made it to the very last class today, which means my last class. All right, what we're going to do, guys, is we'll focus on how to solve equations when you see a whole bunch of variables and not a whole lot of numbers. Okay. Right now, it looks like we've been ganged up on by A, B, and C. Right. So, what I want you to do is, in your journal, when you're writing this down, make sure you understand, in this particular case, we're going to be solving for B. All right? Now, this problem would be really easy if I said, solve the problem for A. I want you to know what A is equal to. If I said, what is A equal to, you would say?
3.
B. That's right. You would say, the answer, Mr. DeVoot, is 3B minus C. That would be the answer for A. All right? In the real world, there are formulas that have more than just one letter. All right? So, for example, before we solve this one, you don't have to write this down. But the volume of a rectangular-looking box or prism is the length times the width times the height. All right? So this formula only lets you know what the volume is if you have the length, the width, and the height. Okay? But if we wanted to rearrange it, say, well, what's the width of the box? You could change the formula. Because technically, you could divide this side by the length. You could divide this side by the height. And over here, you'd have to divide both sides by, that's an L. That's a very good L. Let's pretend it's an L. All right? What happens to the lengths? They cancel out. The height cancels out. So what's the formula for the width of any box? The volume divided by the product of
The length and the height.
Length and height. So if you know, so if I said, Jacob, what's the width of this box? You'd have to say, well, I don't know, Mr. Drew. What's the volume? What's the length? What's the height? And then I could use this formula and so. All right. So far so good? Your formulas have sometimes more than just what? More than one letter. We got to learn how to manipulate things. So that's what we're going to be doing today. So let's go back to our first one. Okay? We're going to be solving for B. Well, I just found it. All right? By the way, the correct answer, everybody, is not. There it is. That won't work. All right, sorry. So, in order to solve for B, the first thing I'd like you to do, we're going to write a sentence here. We're not going to write, don't tell your English teachers, we're not going to write a complete sentence today. Okay? But I want you guys to understand we still need to isolate, write down the word isolate, the, I'm going to put in quotation marks, the B variable. All right? So we're going to isolate the B variable. Oh, I can't see it. It says isolate the B variable. Now, I'm going to rewrite our expression here, our equation. A equals 3 times B minus C. Now, our B variables, technically we have 3 of them. We have 3B. All right? So we want to get that guy by itself. But that guy's got a pesky negative C hanging out next to it. So what's the additive inverse? That's right. So we're going to say, you know what? I'm going to add a C to this side, and I'm going to add a C to this side. And these C's right here totally cancel out. Now, unfortunately, where students usually make a mistake is when they try to combine A and C together. Just remember in your journal, put not like terms. Those are not like terms, because I can't combine those. So how could I write that as an expression where I couldn't combine them? That's right. So we're going to write A plus C is equal to 3 times B. 3. It's supposed to be a B, not a 6. It's 3B. All right. So now that's step 1. Have we isolated the B variable? Yes. Now, how did we do that? We what? We added C to both sides. That's what we did. Now, when I say to both sides, I mean to both sides of the choking side. I mean the equal side. All right, both sides of the equals. All right. And step 2, I'm going to change colors. Step 2. Anybody here want to guess what we're going to do on step 2? We're going to solve for it. By sides by 3. So here, step number 2, we're right. Divide that sucker. I'm just kidding. Divide that by 3 on both sides. All right, divide. I guess I should say each side. My apologies. Like, make up your mind. Divide each side by 2. All right. So now, what happens to these 3? They cancel to a 1, right? 3 divided by 3 is 1. And now, finally, we're left with B. And the crowd cheers. And what's our final answer? It's the sum of A and C all being divided by 3. And that is your answer for number 13. You can put it in your journal, but you can also take that answer and transfer it to your paper. All right? All right, now we're going to do a more difficult one. 15 is not more difficult. It's pretty much the same. This one, number 17, put into your journal. Because that bad mamma jamma has a little bit more difficulty in it. All right? Not a lot more, but a little bit more than the previous one. Now, we're going to be solving for x in this particular case. Now, as you scan number 17, as you're writing it down, ask yourself, so, what makes this slightly more difficult than the previous one? Well, I have an x right here, and I have an x right there. And even worse, the x is stuck in between the 2 and the y, so this actually is a factor. X is a factor of this monomial called 2xy. So, what we're going to learn, what we're going to learn, write this down, learn how to factor out a variable. We're going to learn how to factor out one of those variables when we need to. So in your journal, kind of write that down as the instructions. How did I factor out that variable? You go back and look at it. All right? So before we can factor out x out of an expression, the first thing we need to do is get all of the x's to one side of the equal sign. So our equal sign is right here. All right? So the first thing I'd like you to do is I would like you to take away an x from the right side of the equal sign and take away an x from the left side. That's the first thing we have to do. So step 1, what we're going to do is we're going to isolate all the x variables. Which means we've got to get all the variables that deal with x on one side. So what we did is we subtracted x from both sides of the equal sign. All right, that's the first thing that we did. So on the right side, we're just simply, I'm going to move this equal sign down a little bit more. Equals. On the right side, all we have is a 7. That's it. On the right side, all we have is a 7. Sorry. The left side, once again, these right here are these like terms. Do these look exactly alike? No. One of them has a what? An x and a y. One of them just has an x. So here's what you have to do. You have to rewrite it as 2xy minus x. So write that in your journal, okay? And what I'm going to do is I'm going to rewrite it so we have a little bit more room to work, okay? So we have a 2 times an x times a y minus an x equals a 7. Now what we talked about is we talked about factoring a variable out of an expression. So I want you to think of this. Think of this right here as the expression. And this expression has an x here and it has an x right there. So this monomial, this is a monomial, 2xy is a monomial. And this monomial, x, is another monomial. They have one common variable. And that common variable is x. All right? So watch what I'm going to do. I'm going to take that x, I'm going to highlight it. I'm going to remove it from both monomials. I'm going to remove it or factor it out. So if I factor out, just like when I did that little demonstration when we were in the room, all right? You saw me move off to the side, right? So if I factor this out, what am I going to be left with right here? A 2 and a y. This is just a minus sign. It's an ugly minus sign, but it's still a minus sign. Now, this is where it gets kind of confusing. If you factor an x out, it's not like there's a 0 there. There's still technically a number. Okay? The way you check to see if you factored a variable out correctly is you go back and use the distributive property to see if it gets you back to where you were. So follow the hand. Ready? What is x times 2y? 2x. And what is x times a negative 1? It's a. So this expression here, where the hand is highlighting it right here, that expression is the exact same as this expression. All I've done is factor out an x. Now the cool thing is, how many x's do you see in this expression? How many do you see here? And that? One.
Oh, sorry.
One. That's the magic. That's what you have to do. Because ultimately, when I told you guys at the beginning we need to solve for x, you got to get it down to 1. 1x. What is 1x equal? Alright? You're right. X is always equal to x. I agree. Alright? Now, I'm going to go down here. I'm going to rewrite it. I have x parentheses 2y minus 1 equals 7. And the reason why I'm rewriting it is I want you to see the very, very last step. The last step that you would need to solve for x, where we get this answer called x equals something, your answer, is we also have to divide both sides by the expression that is being multiplied to the x. This x is being multiplied to the expression of 2y minus 1. So we have to divide both sides by 2y minus 1.
So it's going to be x equals to,
What's going to happen to these right here?
0.
They're going to, so this and this are going to cancel because any number divided by itself is 1.
So you think it's 7 out of
That's right, you got it. It's equal to 7 over the expression or the binomial of 2y minus 1. That right there, if you, listen, what's really the only number you need now to solve for x, like a numerical number? You would only need to know what y is equal to, okay, to solve for x. So, I realize that was a little bit more difficult. I'm going to go and pause this right now, and that's how you factor out a variable out of an expression.